All right, in today's lesson here, we're going through a bunch of examples of finding the equation of a line. So let's go through all these examples here. So for the first one, we want to find the equation of a line. They tell you in the question that we have a slope of 7 and we pass through the point 1, -2. So if I have a slope of 7, my equation is going to be y equals, now the equation of a line is y equals mx plus b. They gave me the slope directly here, so the equation is y equals 7x plus b. I'm going to go ahead and sub the point in, because my line goes through this point, so I can sub the point in and that equality holds. So I can get rid of the x and change it to a 1 and get rid of the y and change it to a -2. So when I go ahead and do that, and I get -2 is 7 plus b. Subtracting 7 on both sides, I end up getting here that b is -9. So putting this all together, the equation of the line is y equals 7x minus 9. Let's take a look at another. So in the next question here, they kind of flip the idea on you. They give you the y-intercept and a point instead of a slope and a point. So again, go to your equation. My equation of a line is y equals mx plus b. This time they gave me my y-intercept, also known as your b value. So I can get rid of that b value and change it to a 3. And now I pass through the point. So I'm going to sub that point in. My y value is 4. My x value is 8. And I'm solving for b here. So normally, you put the number in front of the variable, just easier to solve for. And I want to solve for m here, so I'm going to subtract 3 on both sides. So you get 4 minus 3 is 8m, or 1 is 8m. Divide across by 8, I get m is 1 over 8. So the answer to this question is y is 1/8 x plus 3. And that becomes my answer for this equation here. All right, let's take a look at number 3. So for number 3 here, we want to find the equation line that's parallel to x equals 3 and passes through the point 5, -4. So visually, if you want to take a look at what this looks like, is the line x equals 3 is actually a special case. It's a vertical line, has undefined slope, and this is line x equals 3. Well, the point 5, -4, maybe it's somewhere, the point 5, -4, maybe it's somewhere right around here. And we want to create an equation that's parallel. If my equation is parallel, it's going to look something like this. And as soon as I see a vertical line, you know that vertical lines represent x equals to. X equals to what? X equals to my x-coordinate I'm passing through. This is going to be x is equal to 5, and that becomes my answer for number 3. The equation of the line that's parallel to x equals 3 is also going to be an x equals 2 equation because it's parallel. And it'll cross through the point 5, 4. You're going to grab that x-coordinate of that point. Let's take a look at another. So now they kind of flip it on you. Instead of using the word parallel, they use the word perpendicular to x equals to 1 and pass through the point 4, -5. So if we take a look here, I can take a look at x equals to 1. May look something like this. Again, you have your vertical line at x equals to 1. And we're passing through the point 4, -5. This is the point 4, -5. And we're perpendicular this time. So if we're perpendicular, it's going to look something like this. So now this equation here is not an x equals 2 equation. It's a y equals 2 equation. And this equation here, you'll notice, is a horizontal line. And horizontal lines have a slope of 0. So this is going to be 0x plus b, my y-intercept. But again, you just grab the y-coordinate here. So this ends up just being y equals to -5. Becomes the equation for number 4. Let's take a look at another. So the next question here, same sort of idea. Now they want you to find an equation that's parallel to y equals 8. So y equals 8, now they flipped it on us. This ends up being a horizontal line at y equals to 8. I want to create an equation that's parallel to this line. And it crosses through the point 1, 2. Well, maybe this is the point 1, 2. Since my equation is parallel, it's also going to be a horizontal line. Since it is a horizontal line, it's going to be y equals to. Y equals to what? Grab your y-coordinates. In this case here, it becomes y equals to 2. Let's take a look at another. So in the next equation here, you're going to go ahead and find an equation that's perpendicular to y equals to 4. So if I have the equation y equals to 4, I want to find an equation that is perpendicular to it. If it's perpendicular to y equals 4, they use the term origin. And if you look at the term origin, it crosses through the point 0, 0. So if it crosses through the point 0, 0, it's going to be perpendicular, and it's crossing through the origin. It's going to look something like this. And if you see a vertical line, in this case here, this is going to be the line x equals to 0. If you have a perfectly vertical line, and it crosses through the origin, then the equation of this line becomes x equals to 0. All right, let's take a look at another. So with number 7, we're kind of away from those special cases, but the same terminology. You want to find an equation that's parallel to this line. Two equations are parallel if their slopes are the same. So the slope that I want, my equation that I want is y equals mx plus b. My m this time is going to be, because it is parallel, my slope will be the same. So this will be 5x plus b. And now they tell me it has the same y-intercept. Your y-intercept is your initial value, it's my b value, as this equation. Well, I have to find out what is the y-intercept of this equation. So I have to put this in slope-intercept form. So bring this over. Go ahead and divide across by -3. So you get -2 over -3x plus 10 over -3. Two minuses become positive. This becomes y equals 2/3 minus. So you can see here the y-intercept of this line is -2/3. So I can get rid of the b value and change it to -2/3. And the equation of this line is y equals 5x minus 10/3. Let's take a look at another example. So in this example here, they want you to find the equation of a line that's perpendicular to this line. So once again, I need to find out what the slope is. So I'm going to take this equation, I'm going to rewrite it, and express it in slope-intercept form. So I'm going to divide across by -4. And the two minuses become positive, so I get 3/4 x, and I'm going to push that minus sign at the top. We should rewrite this always in lowest terms just to finish this off. So this becomes -3/2. So the equation of this equation in standard form, written in slope-intercept form, is as follows. The slope that I want is not parallel, it's perpendicular. Since my slope is perpendicular, I have to take the negative reciprocal. So I can take 3/4, you flip it and change the sign. So the slope that I want is going to be y equals -4/3 x plus my b value. So now I have to go ahead and sub my point in, right? Because this line passes through the point. So I'm going to sub the point in. Get rid of the y value, change it to -1. Get rid of the x value, change it to a 6, and I put plus b. So continuing this up here, we've got to compute here -4/3 times 6. Now this is over 1. So when we reduce this, 6 over 3 is 2, and this ends up being -8 plus b. And I want to solve for b, so I'm going to go ahead and add 8 to both sides of the equation, and I get b is 7. So putting this all together, the equation of this line is y is -4/3 x plus 7. Let's take a look at another. So for the next question here, we want to find the equation line that passes through the following 2 points. So now they don't give us the slope directly, but I know if given 2 points, I can find the slope of that line using the following equation. I know that the slope of the line is your change in your y over your change in your x. So I can go ahead and label these points. I can label this x1, y1. I can label this point x2, y2. So when I sub this in here, you're going to get y2 minus y1 over x2 minus x1 is 12 over 5. So the slope of my equation is going to be 12 over 5x plus b. Now I need to find my b value, so I can pick either one of these points and sub it in and solve. I'm going to go ahead and pick my first point, so I'm going to get rid of y, change it to a -3. I'm going to get rid of x, change it to a 2. I'm going to solve this equation. So again, when you're multiplying a fraction times an integer, just the top with the top and bottom with the bottom. The 2 doesn't have a bottom, so I'll just put it over 1. This becomes 24 over 5 plus b. And then I'm going to go ahead and subtract 24 over 5, get myself a common denominator. And finishing this off, I get -39 over 5. So putting this all together, the equation of my line is 12/5 x minus 39 over 5. Let's take a look at another. So next question here, we want to find the equation line that is perpendicular to the following line here. So I have to find the slope of this line. So once again, I got to put this in slope-intercept form. Divide across by 7. And now this is in slope-intercept form. Now, the slope of this line is equal to negative 1/7. I want a perpendicular slope. So the perpendicular slope, you're going to flip it and change the sign, you get 7. So the equation that I want is y is 7x plus b. If we keep reading here, they didn't give me the y-intercept, they gave me the x-intercept of 3. Another way of saying you have an x-intercept of 3 is saying that the line passes through the point 3, 0. So I actually have the point 3, 0 that this line passes through. I can substitute that into the equation. The reason I said it passes through the point 3, 0 is if you have a linear relationship, anyone at all, when that linear relationship crosses the x-axis, it must be the case that its y-coordinate is 0. So no matter what the x value is, you always have the property of the y value 0. So if you have an x-intercept of 3, I know the y-intercept must be 0 there. So I'm going to go ahead and substitute that point in. I'm going to replace the y with a 0 and the x with a 3. And I'm going to solve for b. So you get 0 equals 21 plus b, in which case you get b is minus 21. So putting this all together, I get y is minus 1/7 x minus 21. And now I am in slope-intercept form. Let's take a look at another. So for number 11 here, I want to find the equation that is parallel to this line here and has the same y-intercept as this line. Well, to be parallel to this line, I need to find the slope of this line, and it would be the same. So I have to put this equation in y equals mx plus b form. So I'm going to multiply across by 3. So if you multiply across by 3, we have that. And then I'm going to isolate for this equation, divide across by negative 6, and you get 1/6, and then push it to the top. I should rearrange. I should simplify this as well. Divide top and bottom by 3. Now I'm in slope-intercept form. Now the equation that I want is parallel to this line. So the slope that I want is 1 over 6. So the equation of my line is 1 over 6x plus b. I need to find my y-intercept. But if I keep reading, it's the same y-intercept as this equation. Well, the y-intercept of this equation is negative 7. So the final answer is 1/6x minus 7. All right, let's take a look at the final problem. So for the final problem here, they want you to find the value of a if the slope between the 2 points is 5. So they kind of flip the idea on you. You're given 2 points, and you know the slope is 5. So the equation of the slope, again, I can label this in any order I want. I'll label this x1, y1. I'll label this x2, y2. So this becomes a minus 2 over 2 minus 3, in which case I know that the slope is 5. So I have 5 equals a minus 2. 2 minus 3 is negative 1. So I end up getting here, you can multiply across by minus 1 or push the minus sign to the top. If you push the minus sign to the top, make sure you put your brackets around this. This ends up being 5 equals negative a plus 2. I'm just solving for a here. I can go ahead and subtract 2 on both sides of the equation. And I'm going to multiply across by negative 1. I get a is minus 3. So the value of a, that'll give a slope of 5, is a being minus 3. All right, that concludes today's examples here. Just find the equation of a line given parallel, perpendicular, lines, slopes, and y-intercepts. Thank you.